This is Dr.VNSR Venkateswara Rao, working as Associate Professor from the Department of Chemistry in Institute of Aeronautical Engineering, Hyderabad. So today I would like to give the topic on the question bank of the Electrochemistry and Corrosion. So before starting the topic, first you see what are the contents involved in today's session. So first of all, these contain mainly three parts. Part A, short answer questions, weightage is 2 marks, and Part B, long answer questions, weightage is the 10 marks, and Part C, problem solving and critical thinking questions, weightage is the 10 marks. So let us start the Part A questions, short answer questions. So define the terms electrochemical cell and electrolytic cell. So electrochemical cell is nothing but the reaction takes place when the conversion of a chemical energy into electrical energy. Electrolytic cell is nothing but a backward reaction of a electrochemical cell. That means electrical energy converts into chemical energy. So what is the role of the salt bridge in voltaic cell? So salt bridge is the one of the equipment to separate out the solutions of the electrolytes present in different electrodes, both anode and cathode. So for example, if you can take as galvanic cell, it contains both zinc sulfate and copper sulfate solution. These two electrolytes are separated by a salt bridge, and it avoids the mechanical mixing of the two electrolytic solutions. What is EMF of a galvanic cell? How to represent a galvanic cell? So EMF is nothing but the maximal potential difference between the two electrodes present in a galvanic cell, and it should be represented by the galvanic cell, the potential difference between the cathode and anode, and it should be equal to 1.1 volts. Define batteries. How are they classified? So batteries are the one of the electrochemical series which are connected in the series mode, and these are classified into two types. One is primary cells and another one is the secondary cells. Differentiate between the primary and secondary cells with the suitable examples. That means primary cells are the called as disposable batteries. It involves only chemical energy converts into electrical energy. The best example for a primary cells is nothing but a lead acid storage cells, and secondary cells. So secondary cells is nothing but a which involves the conversion of chemical energy into electrical energy and electrical energy into chemical energy. So the best example for a secondary cells is nothing but a nickel cadmium cells. Explain the discharging and charging reactions of the lead acid battery. So that means first of all, it is the comes under category of the secondary cells. So discharging is nothing but a it involves the forward reaction. That means chemical energy converts to electrical energy. So that means the undergoing a lead metal into oxidation reaction, it converts a lead plus 2, and backward reaction nothing but charging reaction. It involves the conversion of electrical energy into chemical energy. So that means it is nothing but a charging process. Write the advantages and applications of the lithium ion battery. So the advantages of the lithium ion battery is nothing but it should be used as a portable appliances and home appliances, and discharging and and applications of lithium ion battery is nothing but it can be acts as a leak proof cells, and it gives a voltage nearby very small voltage compared to other batteries. And what is the single electrode potential? How do you determine the electrode potential of the zinc sulfate? So that means the electrode may be undergo either tendency of losing or gaining of the electrons when it is dipped in its own ionic solution, and we have to determine the zinc electrode dipped in zinc sulfate solution is nothing but a oxidation potential, and should be equal to the according to electrochemical series minus 0.76 volts. Define electrochemical series and write its applications. So electrochemical series is nothing but a arrangement of the elements according to their standard reduction potentials, and these applications are mainly applicable to determine the stoichiometry of the reaction and balancing the chemical equations. Derive Nernst equation for the calculation of the electrode potential. So Nernst equation is one of the equation to determine the electrode potential at a standard conditions, and the Nernst equation is nothing but a E is equal to E naught minus 0.0591 by N log of concentration of products by concentration of reactants. Okay, describe the construction of a calomel electrode with neat diagram. So that means the construction of a calomel electrode involves the mainly reference electrode. So reference electrode is nothing but a which is a non-potential. So that means non-electrode potential. So this potential applicable to determine the unknown potential of another indicator electrode. So this calomel electrode contains the mainly mercury chloride solution. So, and it contains both mercury at the bottom, solid mercury, and before that it having the mercury chloride solution, and at the side tube it having the saturated KCl solution. Saturated KCl solution. So saturated means see that means the solubility product should be equal to the ionic product. So that is nothing but a saturated solution. Okay, and define corrosion of a metals. Write any two causes and disadvantages of a corrosion. So first of all, corrosion is nothing but a degradation of a metal. That means by taking the any metal, it should undergo chemical reaction in the presence of the environment. For example, if you can take as iron, it will undergo say oxidation in the presence of the atmospheric oxygen to give ferric oxide. That means Fe2O3 trihydrate. So now the causes of the corrosion is nothing but generally the pure metals are unstable in the presence of the open environment. Immediately they react with the environment gases like oxides, sulfides, and any other gases. So that means, for example, if you can take as this iron, the oxides reacts with to form a ferric oxide. And the disadvantage is nothing but the metal loses the properties like malleability, conductivity, and ductility, and it loses its physical appearance. And what is pilling bedroth rule? So pilling bedroth rule depends upon the surface area of the metal and coating surface. So according to pilling bedroth rule, if the metal coating surface is more than the metallic surface, what happens? The corrosion discontinues. If the coating surface it is less than the metallic surface, the corrosion should be continuous. That means the metal absorbs the oxygen continuously, even the coating should be takes place. So that is nothing but pilling bedroth rule. What is liquid metal corrosion? So liquid metal corrosion takes place in the presence of a metal alloys and in the presence of mercury. Differentiate between the dry corrosion and wet corrosion. So dry corrosion takes place in the presence of atmospheric oxygen, and wet corrosion takes place in the presence of electrolytes. What is cathodic protection? Explain sacrificial anodic protection method. So cathodic protection is nothing but the metal is forced to be act as a cathode. Why? Because cathode the metal should be safe side. And explain sacrificial anodic sacrificial method. It should be takes place according to electrochemical series. For example, if you can take as iron, that should be coated with the more active metal zinc, and zinc can act as a anode, whereas the iron can act as a cathode, and zinc can sacrifice its life and it can act as a anode. It should be degrading takes place, and the base metal at the cathode should be safe side. So that's why this is the best example for a sacrificial anodic method. What is impressed current cathodic protection method? So impressed current cathodic protection method is nothing but by applying a DC source, the method of the anodic material can be converted into cathodic material. So it should be used as a large pipelines. And write the applications of the galvanizing. So galvanizing is most probably is nothing but the coating of a base metal with zinc. So that is nothing but galvanizing, and should be most probably used in the roofs and cables. These are the main applications of the galvanizing. And what is hard dipping? Give the importance of thinning in corrosion control. Hard dipping is nothing but the base metal should be dipped in a molten state of a coated metal. So the tinning it should be acts as a non-toxic material, and it should be used as a food utensils. What is electroplating? So electroplating is nothing but the coating of a coating metal will be takes place on the base metal in the presence of electricity. Now we see part B questions. These are having the weightage should be 10 marks. And what is galvanic cell? Explain the construction of a galvanic cell with the electrode reaction. So galvanic cell is nothing but it is an electrochemical cell which involves the conversion of chemical energy into electrical energy. And there are mainly two types of the electrode reaction takes place at anode and at cathode. So at anode what happens? Zinc undergoes oxidation, and at cathode what happens? The copper undergoes reduction, gives solid copper. That means finally it lost it 2 electrons. That means zinc plus copper plus 2. This is nothing but a net cell reaction to give zinc plus 2 and copper. That means from zinc to zinc plus 2 what happens? Oxidation takes place. And from copper to copper undergoes reduction takes place. So compare between a cell and a battery. Write the classification of batteries with examples. So first of all, cell and battery. So cell is nothing but either electrochemical cell or electrolytic cell. So that means it involves the both forward and backward reactions. That means in the case of the battery also it can be classified both primary cells and secondary cells. So that means primary cells involves only forward reaction. That means chemical energy converts to electrical energy. But whereas in the case of the secondary cells which involves the reversible reaction, that means it involves the both forward reaction and backward reaction. That means chemical energy converts to electrical energy and electrical energy converts to chemical energy. So and batteries examples are for primary batteries we see dry cells nothing but Lagrange cell. For secondary cells we see nickel cadmium cells. Explain the construction and working of the lead acid battery. Write the discharging and charging reactions and limitations of the acid battery. So we see the lead acid battery. It is the best example of a secondary cells. So that means write the discharging and charging reactions. Nothing but discharging when lead undergoes oxidation. So that is nothing but a discharging reactions. And charging reactions is the backward reaction. That means chemical electrical energy converts to chemical energy. And discharging reaction is nothing but a chemical energy converts to electrical energy. Okay, and limitations of the lead acid battery is nothing but it having a limited voltage potential and applicable only some of the instruments also. And the next one, compare primary and secondary cells. Explain the construction of the lithium ion battery with the relevant reaction mentioned its applications. So first of all we see primary and secondary cells. So primary is nothing but already discussed about, it is a irreversible reaction. So only chemical energy converts to electrical energy. And secondary cells is nothing but it involves the both forward and backward reactions. That is nothing but when chemical energy converts to electrical energy and electrical energy converts to chemical energy. And construction of lithium ion battery is nothing but one of the secondary cells, and it involves the at anode oxidation of the lithium takes place. So that means lithium undergoes with the loss of the electrons, and at cathode what happens? Reduction takes place. And lithium cobalt carbonate, which is the formation of a product, and its applications is most probably used in the portable home appliances, and it having the more voltage. Explain the construction and working principle of dry cell reactions. So dry cell reactions is nothing but a Lagrange cell. So in Lagrange cell what happens? The dry electrode, that means the zinc electrode can act as an anode, and zinc undergoes the oxidation reaction, and it is the mainly depends upon a dry cell, and it can act as a leak proof cells. So that is the importance of a dry cell, and it can act as only primary cell, and it is the example of a only disposable batteries. Derive Nernst equation. Explain how it can be utilized to find the EMF of an electrolyte concentration cells. So concentration cells is nothing but one of the electrochemical cells which involves the conversion of chemical energy into electrical energy by transfer of the amount of the substance from high concentration electrode to lower concentration electrode. And the Nernst equation for the electrolytic concentration cell is nothing but E is equal to E naught minus 0.0591 by N log of concentration of products by concentration of reactants. Okay, so what is an electrochemical series? Explain the electrochemical series with its applications. So electrochemical series is nothing but a electrochemical series is nothing but the arrangement of the elements according to their standard reduction potentials. And this electrochemical series is to be applicable to in the place of the stoichiometry of the chemical reactions, and also to measure the electrode potentials. If the metals have the more active metals like zinc, magnesium, we can calculate the metallic electrode potential. And if the metals having the less active metals like platinum, silver, they are highly stable. So, and we can calculate the potential of those metal electrodes. And based on the electrode potential of a metal, we can finalize whether the metal can act as either anode or a cathode. So, depends upon the metallic nature, the nature of the reaction also takes place. Because always at anode, what happens? Oxidation takes place, and always at cathode, reduction takes place. And what are the reference electrodes? Describe the construction of a calomel electrode. How the potential of the calomel electrode vary with the concentration of KCl solution. So that means first of all, reference electrodes is nothing but a electrode having known potential, and the construction of calomel electrode is nothing but it is having U-tube shape, and there is a side tube, and it is having saturated KCl solution, and at the bottom there is a solid mercury, and there is a platinum electrode, Sidiprin mercury chloride solution, and this can be acts as a reference electrode. Okay, and it should be depends upon the concentration of a KCl solution. So that means it is having saturated KCl solution and its potential nearby equal to 0.2415 volts. Okay, so that is with respect to concentration of the KCl, that may be either 0.1 normal KCl and 0.01 normal KCl, the potential of the electrode should be changes. And what is standard electrode potential? Describe the construction of standard hydrogen electrodes, giving the diagram and the electrode reaction. That means standard electrode potential. That means the electrode potential should be maintained at 2933 Kelvin temperature, and 1 atmospheric pressure, and 1 molar concentration. So these are the conditions when electrode potential converted into a standard electrode potential. And the standard hydrogen electrode is nothing but one of the primary reference electrode. What is standard electrode potential? Describe the construction of standard hydrogen electrodes, giving the diagram and the electrode reaction. So that means the electrode potential should be maintained at standard conditions, nothing but 273 Kelvin temperature, and 1 atmospheric pressure, and 1 molar concentration. Then electrode potential can be converted into standard electrode potential. And the standard hydrogen electrode is nothing but it is one of the U-shaped tube, and there is a platinum electrode, this side tube for the passing of hydrogen gas, and this is a platinum wire. Okay, And electrode reactions is nothing but one of the hydrogen gas undergoes a oxidation reaction at anode, and at cathode what happens, reduction reaction takes place. Okay, so finally we got a net cell reaction, and potential will be takes place, and this can be acts as a standard hydrogen electrode, and the potential of the electrode should be equal to zero potential. Why? Because it is highly difficult to maintain the hydrogen gas at 1 atmospheric condition. And what is electrochemical cell? Explain the construction and the function of the Daniel cell. So first of all, electrochemical cell is nothing but the conversion of chemical energy into electrical energy. And with the construction of a electrochemical cell is nothing but it is mainly having two electrodes. So one is zinc rod is dipped in zinc sulfate solution, another one copper rod is dipped in copper sulfate solution. So this is zinc sulfate solution. This is zinc rod, and this is copper rod, and this is copper sulfate solution. And totally this equipment, and both are separated by a semi-permeable membrane. Okay, and whenever the electrode chemical reactions takes place, the functioning of the main Daniel cell is nothing but a chemical energy converts to electrical energy. That means whenever at anode what happens, zinc undergoes the oxidation reaction with the loss of the two electrons, and at cathode reduction takes place. The last two electrons at anode by taking the copper electrode at cathode and undergoes the reduction reaction. So finally that zinc undergoes oxidation from zinc to zinc plus 2, and copper undergoes the reduction from copper plus 2 to copper. So we observe the redox reaction, and finally understand that the chemical energy converts to electrical energy. So this is the function of a Daniel cell. And what is oxidation corrosion, and how does it takes place? Describe the mechanism of a oxidation corrosion. So the oxidation corrosion mainly takes place in the presence of a atmospheric oxygen, and it takes place according to Pilling-Bedroth rule. And Pilling-Bedroth rule forms a stable oxide film, unstable oxide film, and volatile oxide film. So stable oxide film is nothing but in the case of the ferrous oxide takes place, and unstable oxide film takes place in the example of the aluminum oxide, and volatile oxide film takes place by taking the example of molten oxide. And explain the rusting of the iron with the help of the electrochemical theory of the corrosion. So with respect to electrochemical theory of the corrosion, the rusting takes place mainly two cases. One is anodic area, it should be large, and second one is the cathodic area should be large. So in the case of the anodic area, it should be large. It can be takes place in the presence of a wet medium, and in the case of the if the cathodic area should be large in the case of the dry atmospheric medium. And define corrosion, explain dry corrosion, its mechanism. So corrosion is nothing but a degradation of a metal and deterioration of the metal. So that means in the case of the dry corrosion, what happens, it takes place by the absorption of a environmental oxygen, and in the presence of a liquid metal mercury, it undergoes a corrosion takes place. And what is electrochemical corrosion? Describe the mechanism of electrochemical corrosion by hydrogen evaluation and oxygen absorption. So these are the two cases takes place in the case of the electrochemical theory. So that means in the case of the hydrogen evaluation, it is the one of the theory to explain the electrochemical corrosion in the presence of a wet media. And oxygen absorption is another case. In this case, we observe the large cathodic area, whereas hydrogen evaluation we observe the large anodic area. So that means describe the role of nature of oxide formed in oxidation corrosion. State and explain Pilling-Bedroth rule. So that means in the case of the state and Pilling-Bedroth rule, we observe the oxide film will be observed on the surface of a metal. So these are mainly two cases. Case 1. And second one, case 2. So in case 1, what happens? The surface coating will be greater than metallic surface. So surface coating will be greater than metallic surface. Corrosion should be cut off. So this should be most probably observed in the case of the unstable oxide film like silver and platinum. So that is case 1. And in case 2, the surface coating is less than metallic surface. So this is called as unstable oxide film, and it should be especially observed in the alkali and alkali earth metals. Okay, so these are the two cases of the filling betroth. Describe the process of galvanization of the iron. How does it prevent the corrosion of iron, and mention its applications? So galvanization is nothing but the coating of a zinc metal on the base metal of the iron. So that is nothing but a galvanization process. Because of the zinc is more active metal according to electrochemical series, it will be rapidly undergoes the oxidation reaction at anode, and base metal should be safe side at cathode. So zinc sacrifices its life, and the applications of a galvanization is nothing but it should be used as roofs and utensils and conducting media of the cables. Explain the process of tinning in corrosion control with its applications. So tinning is nothing but the coating of a tinning on the base metal of iron, and these are most properly useful in the food utensils. What is cathodic protection? Explain the sacrificial anodic protection method of controlling corrosion and write its applications. So cathodic protection is nothing but the metal is forced to be act as a cathode. So by applying cathodic protection, what happens? The metal of anodic material should be converted into a cathodic material by applying DC voltage, nothing but direct current voltage. And sacrificial anodic method is nothing but the coating of a base metal of iron with zinc or magnesium. So these zinc and magnesium are the most active metals according to electrochemical series compared to the iron. So that's why either zinc or magnesium coated on a base metal of the iron, what happens? The active metals zinc or magnesium undergoes rapid oxidation at anode, and the base metal should be safe side and it can act as a cathode. So that's why zinc or magnesium sacrifice its life. So this is the process of a sacrificial anodic method. And the applications of sacrificial anodic method is nothing but it should be applicable for a hull of a ship. Explain the impressed current cathodic method, cathodic protection with a neat diagram and write its applications. So impressed current cathodic method is nothing but by applying DC source, what happens? The anodic material should be converted into a cathodic material, and the diagram for the surface of Earth. This is the base metal, and it should be converted into a DC source. Should be filled with gypsum. Okay, so this is the diagram for a impressed current cathodic method, and the applications of this impressed current cathodic method especially applicable for the large storage tanks and large pipelines. Illustrate the reactions involved in the electroplating of the copper with the neat diagram and write the advantages of a electroplating. So that means electroplating is nothing but the coating of the coating of a surface metal on the base metal takes place in the presence of electricity. So that means in the electricity and electroplating, always at anode what happens? Oxidation takes place. So for example, if you can take as a copper, it undergoes a oxidation reaction. And the advantages of electroplating is implemented of the surface coating of the base metal, and it can be useful for the so many domestic items and kitchenware. So these are the advantages of electroplating. So these are the questions coming out from a part C, critical thinking and problem solving questions. That means calculate the EMF of a voltaic cell. The cells is nothing but iron present in iron plus to aqueous solution and copper plus to aqueous solution in the copper metal. So that means when both are separated by a salt bridge. Given the electrode potentials of the copper and iron are 0.34 volts and minus 0.44 volts respectively. So that means what is the basic formula of the EMF is equal to E cell is equal to the potential at cathode minus and the potential at anode. So the potential at cathode and the potential at the anode. So the substitution of these two values, that means 0.34 volts and minus 0.44 volts, we get the positive value at cathode and the negative value at anode. So finally 0.34 minus of minus plus 0.44 volts, we get 0.78 volts. So this is the EMF of a cell. And calculate the EMF of a cell if the reduction potentials of the cell is minus 0.763 volts and 0.337 volts. That means always the positive potential occurs at cathode and the negative potential occurs at anode. So these are also substituted in the formula. We get the value hereby equal to 1.1 volts. Okay, and calculate the electrode potential of the copper wire dipped in 0.1 molar copper sulfate solution at 25 degrees centigrade, and the standard reduction electrode potential of the copper should be equal to 0.34 volts. So for this problem we apply the formula. So that is nothing but E is equal to E naught minus 0.0591 by N log of 1 by Mn plus. Okay, E is equal to E naught minus 0.0591 by N log of 1 by Mn plus in aqueous. So with respect to this formula, we get a value of this problem is equal to 0.31 volts. Okay. And next one, calculate the electrode potential of the zinc rod in 0.1 molar zinc sulfate solution at 25 degrees centigrade. The standard reduction potential of the electrode zinc is equal to minus 0.76 volts. So this is also model problem like the problem 3, and we apply the formula E is equal to E naught minus 0.0591 by N log of concentration of N plus in aqueous media. We get the final value that should be equal to answer. So that is nothing but A minus 0.79 volts. Okay, and next one, the standard reduction potentials of zinc in zinc rod and copper plus in copper rod minus 0.76 volts and 0.34 volts respectively. What is the EMF of the cell when zinc rod dipped in zinc sulfate solution 0.05 molar and copper rod dipped in copper sulfate solution 0.005 concentration? So we get, they give the standard electrode potential. So that is nothing but E naught cell. Apply the formula at cathode and anode. We got the value nearby 1.1 volts by substituting these two values minus 0.76 volts and 0.34 volts. It is at cathodic potential and it is at anodic potential. Okay, and then we calculate the EMF of a cell by applying the formula E cell is equal to E naught cell minus 0.0591 by N log of concentration of products by concentration of reactants. Log of E is equal to E naught minus 0.0591 by N log of concentration of products by concentration of the reactants. So that means when zinc rod dipped in 0.05 molar and copper rod dipped in 0.0005 molar. Finally, we got the answer that should be equal to 1.07 volts. Okay. Next, what is the overall cell reaction for zinc rod dipping zinc plus 2 0.2 molar and silver rod dipping silver solution 0.002 molar, and calculate the EMF of the cell 25 degrees centigrade. The standard EMF of the cell is given 1.54 volts. So this is the model problem of equation problem number 5. We get the value, that means E cell is equal to 1.4809 volts, and if they given, that means standard electrode potential E naught is equal to 1.54 volts. Okay, and why does a steel pipe in large copper tank corrode and causing the rapid corrosion? So because of the electrochemical series, what happens, the steel will be more active metal than the copper, so that's why it undergoes the rapid corrosion. And how is cathodic protection of iron different from its galvanization? So generally, cathodic protection is nothing but the metal is forced to be act as a cathode, and the metal should be safe side. But in the galvanization phenomena, what happens? It should be depends upon the surface coatings. There is no presence of the electricity. That means the base metal of the iron should be coated with the zinc. So it is purely physical phenomena. The cathodic protection is purely electrical phenomena. So that is the difference between the cathodic protection and galvanization process. Galvanized container is not used for the storage of the food products, but the tin coated container is used. Comment on this statement. So generally, galvanization, that means zinc is coated on the base metal of the iron. It is the nature of the toxic nature. So that's why it cannot be used for a food utensils. But whereas in case of the tinning, what happens? Tinning is coated on the base metal of the iron. It is a purely non-toxic. So that's why this is used as a food products. Iron does not rust if the zinc coating is broken in a galvanized iron pipe, but rusting occurs much faster if the tin coating over the iron is broken. So that means in the case of the galvanization, if zinc coating is broken, it cannot be absorbed by the environmental oxygen. But if the tin coating, the tin broken takes place, it will be immediately absorb the environmental oxygen. That's why in tin coating, what happens? Rusting takes place rapidly. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.